many years, wastewater treatment plants. And then they started making some modifications and we became water resource recovery facilities. So that's a little bit more to say, but it is indeed what we are. Everybody is that's able to is modernizing their facility. And yeah, I've been, like you said, I've been in wastewater for 35 years. I started out as a plant operator and was a maintenance and safety coordinator and became chief plant operator and moved up to being a plant superintendent at 2 other facilities. And I'm here and I'm really thankful about that. I was excited when I had the opportunity to come on board because I was told that we were going to be doing upgrades here at the City of East Lansing Water Resource Recovery Facility. And upgrades we have definitely been doing. In fact, we've been under construction now for the last 5 years with different plant upgrades here. And we're very fortunate that we've had that opportunity, that the money has been there to update this facility. City of East Lansing wastewater treatment plant was first built in 1962 here at this site. They had a site over to, there was a small wastewater plant over next to our CSO station on MSU campus. But in 1962, they decided to move it here. And normally the wastewater treatment plants put it in an area that's lowest, so water can flow downhill and have as few lift stations as possible on the way to get into the treatment plant itself. So in 1974, after the Clean Water Act, there was a lot of money available and the City of East Lansing decided to, well, also the demand was there. We needed to upgrade the facility. The 62 plant treated 6 million gallons a day and the 1974 plant treats 12.5 million gallons a day. And they got money. There was a lot of funding going out and they went to secondary treatment. So we have an activated sludge plant on both the north and the south side are activated sludge facilities. And we've been upgrading quite a bit. I'll just touch base on the areas where we have upgraded. Initially, we started with the backside of the plant. We built a new tertiary treatment ultraviolet disinfection building. We use UV lamps now instead of using chlorine. Chlorine was around for a long time. Initially, they were using that back in the 74 plant and went ahead to get sodium hypochlorite, which was not as dangerous as chlorine gas itself. So we went ahead and got the new UV system put in place. And they also retrofitted and rebuilt our sand filtration, which is in the back, up next to our UV system. So that was our first project. Then we went into building a new headworks building, and the headworks building is exactly that, where all the flow comes to the head of the plant when it enters the facility. And we had new pumps, we had new grit removal equipment, we had a new piping to reroute the flow coming into our facility. So that was a big project also. One we are just finishing up on was our solids handling treatment, and we'll get into more of that. But that's we were a belt press, pressing our solids and hauling them to the landfill. And I'll discuss that more. We have a brand new solids handling facility now, which is state of the art. Everything in this facility is state of the art, which is pretty fascinating to watch it come online as it does, because it is state of the art. And lastly, we've been working on new aeration tanks, new clarifiers, both north and south plant. We have new aeration blowers. They're turbo blowers, which is really kind of cool because everything we're doing now, everything we brought into the facility is for energy efficiency. And the energy efficiency there is that we have the new turbo blowers are 2 turbo blowers themselves inside each unit, and the spinning rotor goes on a pocket of air. It's no longer bearings and oil and so forth. It's riding literally in a pocket of air. And from what we've heard, they'll run and run and run, and the maintenance is really low on that. So we are in the process of testing those blowers right now. So that's kind of like where we've been and what we've been doing, and that's where we're at today. And what I should say, why I say we, is because here at our facility we have 8 operators, and we run 24 hours a day, 3 shifts, and we have 4 plant maintenance people, and they're here on the day shift taking care of maintenance. We have 2 assistant superintendents. One is overseeing the maintenance of the facility, and the other one oversees the operations, and then myself. So we were fortunate this past year because we went through the same thing everybody else has been battling with, and that is finding people to replace people when they retire, when people leave. And we were down 4 people, excuse me, we were down 4 people and having a really hard time getting anybody to come on board, which was just the opposite of when I came into wastewater treatment back in 1987. It was not that easy to get in, and once you were in, there weren't positions that opened up. But it's wide open now. We're really begging for people, looking for young people to come into our industry. And we were able to get 4 new employees this past summer, and they're really excited to be here, which is what we want. And they're excited to learn a new field, a new career, which wastewater is definitely changing all the time. It's always something that you can learn, you can grow with. And I was just talking with 2 of the people last night, and they said, we're really glad we're here. They said, we love it. And that's nice to know that our staff is tuned into what's happening out here at our treatment plant. So that's kind of like where we're at and what we have for staffing out here. And everybody's tries to work as a team. We have regular staff meetings where everybody has a chance to have their input, and we have regular safety training at the same time. So we want everybody to know, not just at the facility, but also out in the community, that this is their water resource recovery facility. Michigan State University, Meridian, and City of East Lansing, we all are paying the funds here to make this happen. And we don't take that lightly. We try to make sure we're as efficient in every way that we possibly can be. So, are there any questions yet? Any questions at all about any of what I just said? Okay, so give me just a second here. What I like to do, I have some pictures I'd like to be able to share with you. I'm hoping that they're going to come up on the screen. Let's see here. Yeah. Do I need to hit the share button? I do.
Yes, hit the share screen and you should be ready to go.
So I'll just hit that button.
Yep.
Okay, let's see here. What do I have?
You may have to choose which screen. Once
Okay, I'll
yeah,
just click on that and that'll be good.
should be good.
Oops. I think I went too far. I've got everybody. Okay, very good. Let's see if I can pull up a picture here. There we go. Beautiful. Thank you very much. Okay, I'm starting out here because what this is a human machine interface. And we have SCADA, supervisory control and data acquisition, here at our facility. And what that means is everything here is mostly operated by computer. This here computer screen you're looking at is a representation of our plant. Let me just give you a quick little rundown here of what's happening, where we're at. We'll be coming in here. This is a representation of the south plant. This line right here where it's yellow, this is where a road runs right between our plant from east to west. Everything on the north side here is our north plant. Everything down here on the south side, I'm sorry, I showed you wrong. Here's the road. Everything on the north side here is a north plant that was built in 1974. Everything down this way is the plant that was originally built in 1962. Currently, these tanks right here are long rectangular tanks, and they are our primary clarifiers. We have the same thing on the south primary clarifiers, and these are going to be retrofitted. All the mechanical linkages in here, all the gears in here, all the sweeps that go across the top in here, that's all going to be taken care of. Here again, these round tanks are symbolizing final clarifier tanks, and I have pictures of those we'll look at. These are our aeration tanks where the microlife is growing and consuming the soluble organics, treating our wastewater. And the same thing down here. But this is just one page, and all these buttons here along the side, our operators can click on these and it'll take them to any place in the plant that they want to be at. And they can monitor anywhere in this facility by pushing these buttons. And I'm sure probably you've seen these before. I want to say the first SCADA systems really started coming out, and for me, when it was in Delhi Charter Township in 1992, we went from doing everything manually to having computers running our facility. And that was really cool and very exciting. Had opportunities to take training for the PLCs. And all of a sudden we had a brand new way so that we could monitor what's happening out in the plant and take care of other business, whether it be maintenance on the plant, additional laboratory work, whatever needed to be done. But one thing I've always truly believed, and I'm saying this from experience, and I tell our new hires this the same thing. I said, and even coming up, I've always stated, when we learned the plants and how to operate a plant without the computer, that's because we were out in the facility. We were looking at the color of the tanks. What color were the tanks? Did they look proper? Was there anything floating on the tanks that shouldn't be there? Did they smell right? I mean, there's certain smells that you're just used to, and you can tell something's not smelling proper. You go out and you hear, listen, does it sound right? Is the plant here? Are these motors correct? And so as you make your rounds throughout the plant, and that's one thing we're always doing throughout the facility without SCADA, we made sure we were out in the plant, walking around, looking at the various vessels and listening, seeing, hearing what was happening. And then we talk about it. And this computer's great as a tool, but I told them it never takes the place of getting out in your facility, walking your tanks, looking at your tanks, looking at the foams. The foams make a big difference too. Will let us know right away if we have a problem. What type of foam do we have on our tanks? So while this is a great tool, and it really is a great tool, we can monitor our lift stations throughout town off of here also and see what our flows are at our lift stations. It doesn't take the place of an operator going outside and walking through our facility and sticking tanks. How much sludge do we have there? Those are our solids. Those are our workers that we need to clean the water. We better know where they're at. We better be out there checking the final clarifiers. We better be looking to see what's happening with our aeration tanks. It might sound silly and it might sound old-fashioned, but it's just as important today as it ever was. So we make sure that our new hires understand that, and we walk them through and train them on how to handle the facility. Also, if we ever did have, although we shouldn't have now because we have our combined heat and power system, but if we had a power outage before, you have to know how to run your facility if all of a sudden you're dead in the water. So that's why I started here. Let's move onward here. Okay. Oh, I'm sorry. Let me do this. There we are. This here, I wanted to start at the headworks building here. These are brand new. These are brand new motors. They're 125 horsepower motors. And these are three, as you can see, 1, 2, and 3. We have 3 more facing just on the opposite side. And you can see here behind each one, these are where their controls are at. Variable frequency drives. We can control from the computer screen how fast we want them to go, turn them on, turn them off from up in the operations room. Everything you can do on these screens, we have these human HMIs throughout the plant. So wherever the operator is, if there's something he's doing, a process, he can go to these and look and see what the status is. So these are the motors, 125 horsepower each. And we have 6 of these. And they bring the I'm sorry, 21, 22. They bring there's our pumps right here, vertical lift suction pumps, and each one does 12.5 million gallons a day. So we have plenty of a flow here. There's no problem there. These here big lines in the back, these are raw sewage pumps. There's 2 of these lines here. They suck all the water that's pumped from below, going into the process, into the rest of the plant. The whole function here is to take the water that's coming from MSU, Meridian Charter Township, and City of East Lansing, and start doing the process. Now, it's very important to remember wastewater coming in has all sorts of material in it. It has stones, it has sticks, it has abrasives in it, baby toys in it, there's money in it, there's t-shirts that come down in it. Everything you could possibly imagine that's ever gone down somebody's toilet ends up here in our flow stream. So we have to make sure we get that material out. Otherwise, it can plug our pumps, especially this is really key, is the wipes on TV that they're constantly telling us we can use these wipes and we can flush them down the toilet. And they all say flushable. Well, yeah, they're flushable. But if you have a lot of them down there and everybody's flushing them, then when you start to plug up our pumps, you plug up the pumps out in the collection system, then you would be backing up flow. We don't have that problem that I'm aware of. I have not heard that from our Department of Public Works, who takes care of our collection system, which is good. But if some of the larger cities do have that problem, and they have to literally pull up buckets full of these rags that are down in the collection systems because people see that I can flush these. And everybody, it's not, if you use them, it's great, but you just can't flush them. I don't know why I wish they didn't say flush these down the toilet, but they do. And they can cause a problem. So move out of these where the pumps are here. What we're looking at here is the room. This is a pre-treatment before the pumps. And what's happening is down below the screen right here, about 30 feet down, is the level that all the raw wastewater comes into our plant. And you can see there's 1, 2, 3. These units right here are large rakes, and they're made by DuPont Industry, and they're great, and everybody really likes them. They work very well, and they're made up in Saginaw, Michigan, which we're pretty happy about that we can use that equipment. What it does, it's slanted down, and it goes down further, all the way down to where the water's coming into the plant. And this is like a screen. Imagine tipping this grate up from this end up to here and having it come all the way down. It's similar, it just doesn't have the cross. It doesn't have squares in it. It's just one like giant screening rake. In other words, there's slots in it all the way across, and slots that go all the way up to the top here and go all the way down to where the water's at. And then we have cross members, and they ride in those slots, and anything that's in the water, they pick up. They come out about 7 inches, 8 inches, and they come out and they lift. This is slowly lifting, and they're spaced about every 4 feet. So this is continually going up and around, and it's going back down, all the way down into this wastewater, and it's coming back up. That takes all the heavy material that it can off of the rakes, and it's removing it before it has to be pumped through our plants, part of our preliminary treatment. Over here, it's the same thing, and here is the same thing. Depends on the flow. If we're under a storm event, we turn them all on, because we know that the storm event will flush everything that's out in the collection system, the sanitary sewers. It'll flush it all right at us. And we don't want to have anything plugging up here. So we have these all on. And what they do, you can see this part right here. It's kind of like it comes out and it drops down on the conveyor belt. These are conveyor belts that go all the way down here. And if you look at these chutes right here, this takes the material that comes up these rakes, goes onto the conveyor belt, and at the end there's a piece of equipment on the lower level, about the level just off the conveyor belt, and it screws and pushes. It pushes the all this debris, the cloth material, all wipes and so forth, compacts them, and that comes up these discharge pipes here, and they dump into this Granger container. Same thing happens with the grit on the other side, where the grit is pumped, and I'll show you a picture of that. And that takes all the grit and sand and stones and anything that's abrasive, and it comes out on these two pieces you can see across the way from there. But we've got a little bit better picture, and it removes all that material into the Granger container, and Granger hauls it away for us at their landfill. So it's very important to remove all that out. So now we're pushing clear, still sewage water, but it's rid of all this material that could plug up our pumps and cause abrasive problems with piping down the way. This is the material that drops into the Granger container. You can see here how it's more fibrous, and this whole thing fills up just about the same time, and this was all your wipes, all dried, pushed, and dried out. Granger does not like to take any more water than they possibly have to. They like everything dry. That's because their leachate that leaves their landfill has to be treated, and that is treated in Southern Clinton County Utility Municipal Authority, which is in DeWitt, their wastewater treatment plant. On the left side here, you can see all this grit material. This is like sand and grit and small stones and abrasives. All this material would be going through our pipes every single day if we didn't have it removed. And you can imagine how this would accumulate in other places in the plant and cause problems with our piping, problems with impellers on the pumps, wearing that out and causing more maintenance than is necessary. And that's all expense. These are the chutes you can see up top here. See how this is coming out as a roll? It's how dry it is. It'll go out so far and just drop down into the bucket. This side over here, this just falls out like stones. You can see this little pyramid. This is a grit washer, washes all the grit out. This is a piston grit separator. The grit comes, once the water leaves the raw pumps, it comes down to right here, there's a header, and the water comes up and flows over and comes down a channel here, and there's another one opposite on the other side. There's two of these coming, they're running north to south. And this is number one, and what this is a turntable drive, and there's a shaft that goes down, and there's like big sweep arms down here, about 3 or 4 of them on this shaft, and it's turning almost about an inch off the bottom of this floor here. All the velocity coming through here pushes around and around and around, and it goes down, and there's like, it's conical on the bottom. It drops probably roughly 6 feet down into a conical shaped cone, the grit does. And from the bottom of that cone downstairs, there's piping that's attached to that, and it pumps that grit material out of there and goes into the grit washer we just looked at, and that dumps into the Granger container. So that's called a piston grit separator. That was all new also. Okay, let's see. Okay, now, once all that material is out of the water, it's ready to be treated. And what we have, we're an activated sludge plant, and this is the first of our, this is on the north side of the plant. This is aeration tank number 8. And there's a couple things I'd like to point out to you here. Number one, it's activated sludge, and all the microorganisms, in fact, I should have mentioned this to begin with, but I'd like to mention it right now. Everything that's happening here in our facility, everything that's happening at the wastewater treatment plant is the same thing that's happening out in our environment, in the lakes and the streams, babbling brooks, all the microorganisms we could open. If we had a brand new plant here right now, we could pull open the gate, and everything we need to run our facility biologically would be coming at us right down the sanitary sewer, because all those microorganisms would come in here, we'd aerate it, and we start to create the culture that we need with the microorganisms we need to consume all the soluble organics that are in this tank. That's why it's brownish color, because the loading on it, the humans, we all have to use the restroom, we all have to use the bathrooms, and it needs air for the microorganisms. The microorganisms need to be in contact with the food, so you have the air is creating a turbulence, and the turbulence that it's creating here is a little bit excessive. See here how over here how it's bubbling up And see, as if you were to see it in live, you'd see that there's a lot of turbulence along here. You can see how it's really kind of bubbly. It shouldn't be like that. And I'll show you a picture in just a moment of the new aeration tanks that have been retrofitted and what that pattern looks like, how it's entirely different than what this is. What this is telling us is two things that I know that I'll obviously share with you. Number one, these orange pipes that go down, all these orange pipes here are aeration pipes. They're blowing air. All these tanks have to have air. And so they're blowing air through all these orange pipes down into the tank. And they had what's called spargers. And spargers were long, imagine a long pipe with a 1/2-inch holes drilled in the side for a piece of about 4 foot long. And you have these 1/2-inch diameter holes. Well, you can imagine blowing air out those holes is not efficient. It's blowing it out. It's creating a turbulence. And yes, there's bubbles coming up in the tank. But what we've gone to now is extremely much more efficient. And I'll show you that in just a moment. So when I look at this now versus what we have, I look at this and I'm thinking we're wasting energy. We're wasting electricity. We're wasting a lot more energy than we need to. It's costing us a lot more. No, that's why they upgraded the plant. That's why they decided to go in this direction, because the costs are so high that any wastewater treatment plant is usually the largest consumer of electricity in the municipality where that treatment plant is at, because we operate 24 hours a day, 7 days a week. So here's where we're going. This is modern, kind of futuristic. It's kind of cool. I like it. I look at this and I think, yes, this is where we need to be. Here's that tank that we're just looking at on the right-hand side. What you're looking at here is aeration tank that's empty. What they've done, they've installed these new membrane diffusers. They're rubber, and they're about a foot, maybe 14 inches wide. And they have like a pancake, a flat rubber piece on each of those little pipe plates. I call them pipe plates, but that's what it is. It's got you screw that down on that rubber piece. It's just a retainer. The retainer screws down. And then when we're pushing air, these silver pipes right here, these are all new air lines. When it goes into all these different aeration membrane diffusers, they're called a membrane diffuser, they will kind of puff up like a little dome, and they'll have millions of bubbles coming out of each one separately, just all sorts of bubbles coming out of there. In fact, if someone were to fall in with one of these tanks with all these aerators on, they would probably not be able to get back to the top because there's so much air in there. And the air, again, is for the microorganisms to breathe, to get in contact with their food, but not to waste the energy to get the air there. So we can control this much better, the airflow going into these new tanks. This trough here is also another piece of the puzzle. This is also another reason why we had to upgrade here. What's happening was, initially when they built the plant back in 1974, they designed it for 12.75 million gallons a day per our NPDES permit, which tells us what we have to treat, what our limitations are. How you can look at it two ways. I say how clean we have to get it. Other people say to prevent how dirty the water is that would leave here. Well, the water's not dirty. We always are below their limits, the limitations that they put on us. If we're not, then we're in violation. So we make sure that we treat the water here, and when it leaves here, it's meeting all the permits that are put on us. So what they did, what we did is the construction here that's going on, we're going to have 4 of these troughs, and it will allow us to have more flow through our plant, because the Achilles heel for us was the fact that these gates were too small, and this was where the bottleneck was in these aeration tanks. The flow would come in during a storm event, and we'd have a very difficult time treating it all. That's when it back up. When it backs up, it goes to our CSO station over on MSU campus, and we can only treat that with chlorine, with sodium hypochlorite, and we settle the solids and chlorinate it, and it goes back out the Red Cedar River. When we can't treat it all here, it backs up and goes to this CSO station, and then it goes into the Red Cedar River. But now a couple weeks back when we had that 5 days of rain, we were pushing for a while up darn near in the high 40 million gallons a day, and the upper 40s. So which is really good for us and really good for the plant, because we can treat it, and we treated it all. We weren't in any violations after all that rain was going through here. We had the water level right up to the top, right along the sides here, but we were able to treat that load. Okay, this is tank number 17. This is the last tank in the train. But see how this pattern looks so much different than tank 8 did? See how smooth this is and crisp. You can almost hear it. I can, because I've been around it so much, but you can almost hear these bubbles just sizzling as they're popping across this. This is nice. This has a membrane diffusers in it. And this is a pattern that you're seeing here. Same thing next door on the aeration tank next to it. So this is all of these aeration tanks on the north side and the south side are going to have membrane diffusers in them. We're still, obviously, they're working on it here to make that happen. But once that happens, then we can really control the amount of air in a fine manner. And we're going to, by being able to do that, we'll be able to save energy and cut down our bill. Our monthly electrical costs have been anywhere from usually average around $100,000 to $110,000 a month for electricity. And we're hoping to drop them down quite a bit once these are all up and online. We're hoping to shave 30 to 40% electrical costs out, but we'll find out for sure when it happens. So that's our goal. That's what we're aiming for. This is another look at that trough I was telling you about. How big, and these are much larger and wider than what the passes were before. And this is also going to make it to where we can run 2 of these tanks together as a unit, or to drop 2 tanks out. As like right now, for instance, MSU is gone for 4 months. We will not need the full capacity that we have, the tanks running to handle the load once they're gone. You're talking 35,000 students that are all of a sudden are gone, kind of similar to looking at the city of Mount Pleasant moving in and moving out. So it's a lot, and it's a lot of loading on the facility. But now's the time. The weather's going to be dry for the construction to really ramp it up and get in. They really want to get a lot done this summer. Here's the men down at the far end. I just have this picture in here because I want you to see and understand it's a lot of work. It's a lot of work cutting these gates out and having these gates fit properly. The new gates that they're putting in here, and before they could even do that, where they started was they patched all any concrete that was scored or abrased here on the walls. They did, in fact, that looks like they were doing some patching there. And it takes man work, it's manpower, and these guys, I tip my hat to them. They really know what they're doing, and they're doing a great job. Again, you can see all these membrane diffusers along the bottom of the tank and the new air lines here going down. But I really appreciate the work that these guys do. They do a great job for us. That's Granger Construction, and it's in fact, I'll tell you right now too. I want to make sure I told you this. During one of our construction meetings, I was told. In fact, they told us. Our electricians told us. Our mechanical workers told us this. Mechanical contractors and Granger. They all said this is the most difficult. They're really glad that they got to this plant at this point in their career, because in order for them to work, in order for them to take this job, they knew that we were requiring that we were never going to shut down totally either side of our plants if we didn't have to. I mean, that they had to do this work and keep us in permit, keep us out of violation. So everything that they're doing, they said, in order to make this work, this is the most difficult job we've ever had. And we really have to think this one through. And I can say for myself that I've been on 2 other plant upgrades like this, not this big, but 2 other plant upgrades. And it's really nice when you have great people to work with, your contractors that come in, and we all, the staff here and our contractors, we have a really good team relationship going. We really think, work together, really try to do everything we need to make this happen, which is nice. I'm sure you've all had the opportunities also to where sometimes you're working with a certain group of people where it just clicks and it works right, and you're thankful for that. And that's how it is right now. So again, that's just a picture. It gives you a little bit of an idea of the size of these tanks. This is a clarifier, and the clarifier here, after you have you remove your grit, you go through primary tanks. And primary tanks, I didn't show you a picture of a primary tank, but it's a long rectangular tank also. What happens there, it does two functions. One is to float the floaties and settle the solids. So any of the solids coming through will drop to the bottom of the primary tank, and any floatable material, whether it be grease or anything else, floats to the top. And these and there's sweep arms like about this high. Oh, I'm sorry, about this high right here. And it's an elongated tank, and they'll move across the top. These bars move across the top of the primary tanks and push everything floating on top down into a trough. And all that material is, a lot of it's grease. So all that grease is pumped away. The scum and the grease is pumped and goes to the digester. And this here secondary clarifier, its function is also to settle the solids that come out. What happens here is once it goes out of aeration tank number 17, we go into a splitter box, and we have 3 of these tanks. This is 5, then we have 6, and number 7. And all these tanks are going to also, I wanted to show you this, these catwalks, the mechanicals here, this skirting here drops down about 4 feet. The activated sludge that goes into the splitter box comes up through the center column here. You can see how it's still brown in there, and it goes down underneath like a mushroom head. It goes down underneath the skirt and does a 360. It comes down and starts to come up a little bit, and it settles all out all around this tank. Any of the solids that are in that activated sludge, it all settles to the bottom, which is about 2 foot of depth you want to keep on the bottom of these tanks. And what they're doing, the microorganisms, they've eaten in the aeration tanks, and they're full, and they need time to rest. So they come into these flock tanks, the final tanks, and settle down to the bottom, and they stay in there about 3 hours, and then they come on back out. And they're recirculated back to the aeration tanks again. So they're the real workers of wastewater treatment. The microorganisms really clean the volatile organics out of the water and clear it up. In fact, you can see right here where I'm pointing with this arrow, you can see the cross membranes across here, and that's about 1 foot underneath the water. But see how clear that is just from this far back. You can see how the clarity of the water is so much better than obviously the activated sludge in the center. And this flows over this right here, this weir. The clear water flows over this weir, and it's collected. When it leaves these final clarifiers, it's taken into sand filtration, and any solids that are left in the water, very fine solids that are left in the water, are go through a sand filtration and are caught in the sand itself, caught in the sand filtration. So it's very clean when it's discharging to the Red Cedar River. Before it leaves the sand filters, it goes through the ultraviolet disinfection process. Then it goes out to the Red Cedar River. But all these are going to be exchanged. All these 3 here, everything, all the mechanicals are going to be brand new. And it's time. You know, they've been in service a long time. These are two new clarifiers that they built, that they're building. In fact, they're built now. They're completed now, and you can see the men here that were working on this early spring and through the summer, through the spring, last winter, they started it. Here's your center piece here. All new mechanicals here. I have a couple other pictures to show you of that. And the reason why we have 2 new clarifiers, again, what that does for us is, say we have a high surge, say we're pushing upwards to 50 million gallons a day. Now that water's coming through here and it's coming out underneath the skirt. Again, it's about 4.5, 5 feet deep. The skirt is right here, this round structure. And the water goes underneath it, 360 degrees around that, and plumes on out. One of the things, two new features that I really like, and I'll be able to show you better in another picture, but I'll tell you what they are here, is they have what's called a Stafford baffle, and it goes all the way around the inside of this tank. And it's about 3 foot wide, and it hangs down off the wall at a 45-degree angle. So if there's too much velocity coming out of this tank and heading toward the wall, because it'll come out and it'll go underneath the skirt, rush across the floor, and come up this wall. All of a sudden, it hits that 45-degree baffle, and it turns itself back toward the floor. So it helps keep the solids inside this tank. And we have a solids number we have to be below every day when we discharge, and it helps us prevent any violations. And also, I'll show you in another picture here. Let me get to it. We have covers. Yes.
Sorry, I just want to remind us, we have about 15 more minutes. I just want to leave a little time for Q&A, but I want you to get through your slides. So.
Yep. Okay. I'm going to start kind of moving a little faster. Okay. This is one of the new ones that's done. It shows the truss underneath, the sweep arm across. This goes around about once every 3 minutes, I believe it is. So it goes relatively slow. So you can see what this looks like. Right here is what I want to show you. These white covers here. These are to cover the effluent weir so that algae doesn't grow there, and we don't have to spend a lot of time cleaning those troughs up all the time. So that will be nice. That helps eliminate that. That's the two together. Here's a finished clarifier here, and the other one next to it sitting over here. And in fact, we did put them online during our storm event. This is the Red Cedar River. After it's gone through ultraviolet disinfection, this is where we discharge. Here's the path over here where people are. This is the exit off of 496 coming down into East Lansing. This is our outfall, and this is a goose that we scared when we were taking the picture. But it's pretty nice out there. It's really nature. I think there's another one sitting over here. And but when it rains, in fact, when it rains, it gets halfway up this wall here of the outfall structure itself, and this gets flooded out with water. So, but this is where we're going back in. You can see the water's nice and clear. There's no sign of any problems there. Oh yeah, let's talk about this a minute. This is our new pump building for our solids handling. We have brand new, what we have, the solids that are coming from your primary solids and secondary solids that are wasted, any waste material and our primary solids on the north and south side, and then wasting material north and south side come here, and the scum all come into tanks along this wall here, 200,000 gallon tanks, and they're blended together. And they're heated here in these heat exchangers, and they are sent up into the digester that we have here. I'll show you that digester. And this is the heart of everything that's happening with the solids process. These pumps here recirculate, keep everything in recirculation, so all the solids don't settle to the tank. The heat here and these greens where they say glycol, we use the heat from our combined heat and power of the generator to keep our digester heated. These are digested sludge pumps also that are taking digested sludge and pumping them across the way or recirculating. The pipes can had all sorts of different directions. We can keep it recirculating into the tank or across the way into the solids handling. I'll show you that. This is our digester itself. And digester itself is probably one of the most popular ways to reduce solids at a wastewater treatment plant. It's an anaerobic digester, which just means in the absence of air, this does not have any air in it at all. The sludge is pumped into here. Given time, it grows methane formers. The methane formers continue to off gas, fill this dome here is full of gas, and then the gas from this dome, which is methane gas, is sent to our combined heat and power generator. And the generator runs from it, off of it, and it's a mixture of biogas and natural gas, and generates electricity. The electricity that's generated offsets the price of our electricity. And if we did lose power, we'd have this power source. This is a picture here. There's a digester on the other side of this building. This is your, you've got siloxane taken out here. This is for moisture taken out in here, the biogas coming out of this digester because it's very wet and very corrosive. And we have siloxanes that are hydrogen sulfide taken out here and siloxanes taken out here. So all that comes out of the gas stream before it goes in here. Here's an exhaust vent from our generator where they're generating electricity. This is a screw press. What happens once that our digester operates every day, we're pumping sludge to it. So when we pump sludge to it, it's going to overflow the top and it displaces so much digested sludge out of it. That digested sludge that comes out of it has to be dewatered. The water has to be taken out of it before we can send it to the landfill. So it goes into one of these screw presses. We add polymer to it, and this is a screw press, and it's like a large screening that comes down on a very long cone, and there's a screw in the middle of it that rotates, and there's a screen on the outside of that, and the polymer mixes it and helps hold and bind the solids together, and it's able to squeeze the water out. So it comes into like a cake material, drops down here in the bottom of this pump, and it's pumped through. You can see it's squirrely right here. It pumps through there and up into piping overhead. And it comes out these chutes. So you have dry cake that's been dewatered that comes out these chutes right here. And they fill these Granger containers. And in the past, we only had one container, and now we have 4. But we used to take, we're taking like less than half the amount of containers to the landfill now than what we used to. So we saved, really reduced. That digester has reduced the solids that we used to send to the landfill. So we're really glad about that. We're saving probably 30 to 40% solids reduction on a continual basis. This picture here, I have one picture after it, but this picture here, I wanted you to see, this is on the south side, the south aeration tank. Again, you can see how turbulent this is. That's because all of those sparger lines have been, one way or another, they're fouled, or the holes have gotten so big, they're just blowing way too much air through them. So that's, again, another reason why that's going to get all membrane diffusers. And this is the last picture, which is an air header system. I just wanted you to see how all the air is above board, going to various parts of the plant that need the air. And so that is where we're at today. Kind of like a synopsis of what's happening here and the kind of neat things that are happening, all the construction going on and how it's going to save us a lot of money. It's going to be much more efficient and kind of the way that new wastewater plants, water resource recovery facilities operate. A lot of us SCADA, don't need the manpower that we've had in the past. When this plant was first built, 1964, I believe I've read in the manual that they had between 40 and 60 people working here. And now we have like 16. So that's pretty efficient thanks to the SCADA system itself.
Thank you so much, Todd. That's a really amazing operation you got there. And there is a question in the chat window. Bill McConnell would like to know how much energy the digester produces relative to overall plant consumption.
Okay, well, I can tell you it's producing 633 kilowatt hours, 633 kilowatts. Our generator is. We had some issues trying to keep the generator up and running. that would necessitate us having to fall back onto the natural gas to keep it running. So we've really just got it going now. Well, we're looking for a straight run, an extended period of time, so I could give you that figure. I'll be glad to get that figure to you, Leroy, and or one time when I come on one of your next meetings and be able to give you that information as soon as we have it, because that's something we've been dying to find out ourselves. So
Sounds good. There's another question in the John.
Todd, the presentation was great, kind of explaining how everything works. I'm wondering, I know you've done a lot of electric savings measures before, the big one that's coming up 30–40%. I'm wondering what that percentage has been over time. I know, it probably over the past 10 years, you saved a bunch of electricity. And the second question I have, I'm kind of curious, does your wastewater, the volume of wastewater, is it increasing over time, decreasing over time?
that's a good question. I think it's holding pretty much steady. It's not increasing as fast as what I would think it would. And I only say that because everything kind of came to a standstill with, believe it or not, when COVID came and everything was all of a sudden, well, of course, we've noticed that the students were gone from MSU right off the bat, but it never, and this is the first year where it sounds like they're going to have a lot more students again. So we're looking to see where we end up this year as far as the numbers go here at our facility. Electrically wise, yeah, that's the $1 million question right now is how much energy are we going to be able to save when all this is done, when we're done, when we have the aeration taken care of, when we've got the aeration blowers are operating right now. We've seen some savings. I couldn't give you an exact figure though, and I hate to put a figure out there just to have a figure to give you, but I will tell you this, I will definitely keep you posted as we're going to let you know how much we are saving, because again, we had issues trying to keep that the CHP generator running. It was a series of events. Unfortunately, it kind of happened through one vendor that finally was able to help us out with that. So I will keep you updated because I would like to be able to brag about it, but honestly, I just can't do that yet.
We have another question in the chat. Amanda?
Yeah, I'm curious, I guess a two-part question. Has toilet paper itself been a problem, like these flushable wipes? And the flushable wipes seem to be a universal problem with wastewater treatment plants. So I'm wondering if you know of any efforts to, repeal the flushable language, which is so harmful.
Number one, toilet paper, by the time it gets here, you would never know it was in the waste stream. Also, human waste, by the time it gets here, you'd never know it was in the waste stream other than call it. Also, as far as language, no, I think it'd be a great idea. I don't know why they want to. I do know why. It's for profit. They're not making those free, but it's a great product. But it's just advertising wrong, and in large cities, it creates a major problem where the maintenance crew is out there lifting large pumps out of their lift stations that are just packed full of racks and wipes, and it creates a really major problem in a lot of larger cities. So yes, it does. It is a problem. Thankfully, we like here in East Lansing. It hasn't been a major problem, but it would be if everybody started doing that. If everybody started putting everything down the toilet at the same and not aside in a receptacle. Yeah, it would be a major problem. And apparently people are thinking a little bit and not doing that. And that's appreciated. They're thinking a lot, because if everybody was doing that, we'd have a problem.
I know it's been an issue here in Meridian, clogging pipe pumps. Bruce, you had a question.
Yeah, I was wondering if your plant pays attention to microplastics, and if so, what's being done?
We do not test for microplastics. I have seen some good seminars where they did have indeed discussed the microplastics all across the Great Lakes. There's issues with our microplastics, but it's not something that they have regulated at any plant that I've been at as of yet, for us to even to look for them. But yeah, just the microplastics, I mean, everybody thought it was great. I did anyway, when we first got soap with some rough kind of, and then we found out later on, it was like some of it was microplastics, you know, you felt better to scrub your face, literally scrubbing it. But yeah, there is nothing right now that I'm aware of that's making anybody test for any microplastics.
All right.
I would like to say one other thing here real quick. If you have any friends that are getting out of high school or going into college, head them our way. Wastewater is a really great industry to get into. I mean, it's wide open, and once they're in, if they like science, technology, engineering, mathematics, if they like working on equipment, you know, maintenance wise, if they like working in the laboratory, if they like administrative or working with computers, SCADA systems, everything's here for anybody to get in and really find that they have a great opportunity. You know, you could always write down Water Environment Federation, WEF.org. That is the national organization with umbrellas. Our umbrella here in the state of Michigan is Michigan Water Environment Association, Michigan Water Environment Association. And that lists all the different plants, and they have various, it's a great organization. I've been in it since I've been in wastewater, and they have great learning opportunities for everybody that's in wastewater. I tried every young person, anybody, in fact, they're looking for work, depends on what they're doing. I try to steer them our way. It's wide open, and we are in need of people.
Quick question, pop in the window as part of Bill's question about electric supplier. Are you Board of Water and Light there?
Yes.
Okay.
Yes, we are.
Any other parting comments or questions from anyone?
I would be pleased. I'd really like it if you all want to come out sometime and take a tour.
I would enjoy that.
You're more than welcome anytime.
Thank you, and excited about the improvements. And yeah, that's been brought up a few times. So let's try and find a time. Are there general times of the week that are better?
No, if you think of a time and a date, the weather's going to be getting nicer as we move into summer. We can work it out.
All right. Any other last minute? We have one more minute here. If anyone has any parting comments or questions.
I do want to let everybody know that there's a Mid-MEAC land use lunch this Friday, which is the environmental coordinator for East Lansing, I think, is the speaker. He's going to be talking about their No Mow May. And also, I guess they're trialing a pilot AI program that is going to be on their recycling trucks, where they actually look at contamination right at the pickup. So that sounded kind of fascinating.
Interesting.
Janet Brown.
Thank you, Bruce. I talked to Cliff, and I guess they've got over 300 people signed up already for No Mow May.
Wow.
And that's just official signees, but
Wow.
interesting to hear. Anyway, thank you, Todd, so much. And thank you, everybody, for tuning in. Recorded this. So if you want to review the recording or share it with someone else, you're welcome to do that. If you don't get the email from me later today, feel free to email me for a copy.
Thank you,
And-
Todd. It was super informative. Really appreciate it.
Thank you.
Always a joy to hear somebody who enjoys their work so much and is so passionate about it. Thanks.
Thank you very much.
I hope to
Yeah.
see some of you next week, if not later this evening. Have a good one.
Later.
Thanks, Todd.
You bet.
Bye-bye.
Thank you.